Now that we've covered the organizational structure of a typical NetOps team, we can see that escalations are a common occurrence. And of course, repairing those problems and incidents is something that we want to have happen as quickly as possible. Let's cover some of the needs and challenges before we dive into the NetBrain methodologies developed to help meet these needs and overcome the challenges we've identified. The first need we see is the ability to triage incidents and problems. Triaging is the ability to assign degrees of urgency to incidents that present themselves. The challenge here is that the domain and how-to knowledge is at the top of the ladder, and the requirement to triage is much earlier in the cycle. If everything looks like a problem, then it's impossible to differentiate one from the other. It is much like a project manager trying to prioritize across everyone else's number one priority. If they are all number one, then there is no difference. When I think of triaging in the network world, I also think of the ability to group potentially related incidents and escalate to the appropriately skilled staff as soon as possible, raising awareness that this may not be just an incident, there is likely a problem. From this point on, the front lines can send out a broadcast message to the customers saying that we are aware of the problem of a specific area, check this location for updates, and we will communicate progress in a certain way on a regular basis. This avoids additional tickets related to the issue and protects the scarcer resources up top. We touched on this before, but having accurate and relevant documentation with a visual aid significantly improves the escalation process. An escalation engineer may look at the path and be more familiar with the changes in a specific area or device. If they just see an IP address and a traceroute, it may not be as apparent. Also, a repair engineer looking at the visual may ascertain that the change will impact more than one element and quickly assess that the segment needs to be isolated from the network or that the change be made in a maintenance window instead of ad hoc. The challenge is that CLI sessions are text-based only, and most NMS GUIs are device views only. This makes it very difficult to make decisions that are path-related. Also, since CLI is raw data, it can be very difficult to correlate data from multiple devices in the different raw data files. Having the data and analysis that was previously performed at hand makes operators much more efficient in that they do not need to re-mine the data, which will take additional time that is simply redundant. The same goes for a repair exercise. If the ticket owner has documented what needs to be fixed and why, then it becomes really easy for the repair engineer to potentially take a quick second look and regardless make the proposed change. As we've seen before, the challenge is that raw data and CLI logging sessions can quickly become overwhelming since it's not sorted. It almost makes more sense for the escalation or repair engineer to start the process over again than it is to sort through this verbose data. If NetOps is using a traditional GUI, the steps taken, data collected, and analysis performed are lost. Closely related to this is the fact that ticketing systems and fault isolation systems are very separate tools in most organizations. What most commonly occurs is that the raw data is captured in a CLI logging session, and then a summary of the actions taken and the hypotheses are added in short form into the ticketing or help desk system. It is the ticket that is escalated with often very cryptic messaging. What would be really nice is to have a vehicle that contains a relevant visual aid, all data collected presented in a logical, time-stamped manner, and with the results of all the previous analysis right up front so efficiency is gained. Lastly, when performing repairs or changes to the network, NetOps engineers need a repeatable process that allows easy execution of the change, easy analysis of the change's impact to the network, a way to roll back should the change not achieve the desired result, and lastly, a way to create a document for the change and a way to update the network documentation so it is still relevant for the other users of the network. Unfortunately, most changes are made ad hoc in order to ensure that the MTTR is low and customer experience is high, but network documentation is not updated, causing a snowball effect of future outages that could have been avoided. In summary, we've seen the two major goals of NetOps is to increase availability and reduce MTTR. Lowering MTTR being the most important metric in a NetOps organization. There are four major pillars to NetOps. They are document, isolate, repair, and escalate. Regardless of the pillar, documentation finds its way into all of them. The common challenges are inefficiency in data mining, analysis, and knowledge transfer. Documentation is a time-consuming effort with legacy tools, which leads to more and longer outages. And the expert-level resources needed to solve problems and create documentation are the least available resources in a NetOps structure, and often used for tasks that could be accomplished with more enabled first and second level support tiers. Lastly, legacy tools and organizational structures make it very difficult to increase availability and lower MTTR. Yeah. Lastly, legacy tools and lastly, legacy tools and organizational structures make it very difficult to increase availability and lower MTTR based on their serial nature and raw data logging capabilities.